Thank you, sir.
All right, so today we are going to continue where we left off yesterday. A couple of questions that I got, and on the call yesterday, someone asked the question, "Where did C come from?" And I tried to explain, but maybe because of the network issues, you didn't get my explanation. The C did not come from it didn't come from the heaven. If you look at the mathematical equation that we have, that yesterday, well, the systems we're using now doesn't have that notebook. You recall that there is a matrix that has S naught when we transform mx plus c into two matrices multiplying one multiplying the other. So there is x naught plus 1, x naught plus x naught 1, x naught 1, x naught 1, x1 1, x2 1, x3 1. If you recall, when we multiply that by m and c. Now, what you had extracted from your data is only that x part. You need to put that 111 for you to have what you summarize as x. So for you to put that 111, you need to introduce a column. That column can be called anything. We called it C. Originally, I wanted to call it something else. I just call it C. Is to introduce that 111 to make that matrix a complete matrix. If you remember when we were doing the proving, we did y0, y1, y2, y3 equals to, and then we had that mx1 plus c plus e naught, yes, something like that. So we have mx1 plus c equals plus e, and then mx2 plus c plus e, something like that, right? And then we grouped everything together. I don't have a pen today. I will have, show you what we talked about. So I can still do something. I will do something, but let me stop sharing the screen first so that I can have, let me just do, because so let's get this data, the data set and data. Let's get that. I'm not sharing my screen, I suppose. So data and data sets, please let me know when to continue. I need our maximum attention. So please let me know when to continue. Let me know when to continue, please. All right, so the next thing I'm going to do is to import my numpy, and then read in every other thing appropriately. All right, so let's say we import numpy, and then maybe we use an alias for this one as np. Okay. All right, so the next thing I want to do is just read in the data. So let the data be equals to, I use my pandas to read CSV, right? Read underscore CSV. If you use tab, normally it should give you, and then you read in this one, data.csv. All right, so let's see what our data looks like. All right, so if we do this, all things being equal, we see our data set. We saw yesterday how we can introduce, or how we can get, if you need to get all the columns available within your data sets, all we need to do is just say data.columns, and that's effectively returns the columns that we have, and then tell us the data type that we have. So in this data we have some not to define data, so we have objects. It defines the data type as objects. All right, we equally told ourselves that if we need to introduce a new column in here into this data set that wasn't originally existing, all we need to do is just say that we reference that data, and then we pass in the new we reference that data with the square brackets, and then put in the new column that we want to put in here. So let's say we want to have a new column, just to show us, because you will be needing that new column. This can be named anything. Let's say you want to pass in the same data. So when you introduce a new column, you pass in data by default. So you want all the data that you pass into that new column to be 2. And then now if you check out what your data is saying, then you have a new column is passed, and then you have the value that you passed in, like that, to be 2. The data we have by default has 145 rows, and now it's having 3 columns. Originally it was just 2 columns, so you can pass in as many new columns as possible if you want. Now, so without doing that, you can hear me. If it is not correct, that's when you're going to get columns. Is columns.
C-O-L-U-M-S. Right?
C-O-L-U-M-N-S.
Okay. Let me run it. Okay. Yeah. Thank you, sir.
Works, right?
Yes, sir. Yes, sir. Thanks.
Okay, great. So the next, please, I mean, not since I'm listening, next time if you want to, you may also speak. If you have to call me back, I was just lucky to see you raise your hand. Please, if anybody want to ask question, you can interject by talking. Okay, so we want to go straight into writing our formula. So the first thing we want to do is to get out the x value here. This is already labeled x, and this is already labeled y. So it's the basic data. So let's say this data has been pre-processed, and then someone already labeled dependent variable from independent variable. Most of the times you are going to have to figure what you want to use as what is changing and what depends on the other, just like we did yesterday. Now, so let's get out only the x value from here. So I'm just going to say that I will call it x for the sake of, so we say x to be equals to data, the data that we have. We are going to get out only the x value from it, right? So we have this x. All right, so we do that and we copy it out. Now, so we check out our x value. we'll see something like this as our x value. We'll see something like this as our x value. Please do the same. Now, the next thing we are going to do with this x is to introduce that unity, that 111. All right. So to do that, we just say x. Then this time around, I want to call it unity. Unit column. Then I pass 1 into it. Now, so if I look at the configuration of x, I will have something like this. Unit 111, like that. So pretty much like we did yesterday. So the next thing I'm going to do is to rearrange this such that, you know, this unit comes first. Okay, so I'm going to have my x be equals to x such that this unit is the first in line. The unit is the first in line, and then the x value, you know, comes second. Now if I look at the configuration of x now, this gives us the same thing, but just one column coming from the other. Please be following. I hope you're following and we're doing the same thing. Can I continue, please?
Yeah. For me, so
Multiple people want to join. Okay, great. So the next thing we want to do is to get the transpose of x. So we know that we are done with x, then we'll begin to deal with y. So assuming we call this guy x transpose, assuming we call this guy x transpose, so x transpose is just equals to x dot t. That's the wonder of pandas. Panda reading this guy in has done so much to the data that your data doesn't have before. So when you just do x dot t, because you read it in through the pandas, you know, if you echo out your x transpose, you would see that you have the configuration change, rows changing to columns. Now, so we've got S transpose. All right. So the next thing we want to then move on to is to go and get out the y value, the actual y value. So the actual y value is equals to, the actual y value is, we just come in here and extract data, and then we have y here. So this is equals to y, sorry, it equals to data, then we have y value. Then we're just going to copy that out. We don't need, in our formula there's nothing like y transpose, so we won't need to get a transpose of y. So if we do this and see the configuration of y, we'll see what y looks like. Please, are we following?
yes, yes, sir.
Yes, sir.
Yes, sir.
Now, so remember your coefficients. So in Python, hash is comment. So whatever you in programming, comments are not executable. Whatever you write in your comments are just for what it says. Remember your coefficient value that we derived yesterday, which is equals to the inverse, is equals to the inverse of x transpose times x multiplied by x by itself, right? Then times this one is let me use big X here, so that because I'm using X as this is times or multiply by X, then times the X transpose again. I'm just writing the formula so we can recall it, because we just want to code out. So times S transpose, then times Y. Now let's separate concerns. Let's get the inverse value. So let me say that we have this one called inverse value. All right. Inverse value. My inverse value is equals to, so we're going to be using numpy. I don't know how we imported numpy. Is it as np? We imported numpy as np. So we are not going to be using numpy here. We'll use it as np. So numpy has a lot of methods in it. It has a lot of method in it. One of it is the linear algebra. One of it is linear algebra, right? So numpy dot linear algebra, within it you can get inverse. So if this system is, you know, giving you intelligence, if you just use a tab, you should have, so I think I didn't configure this. If you have a tab like this, so you see this guy here. So this same thing here, say np, if you hit that your tab, you see everything. So you don't have to be cramming them, because if you cram in programming, there's so much to cram and one can run mad. So but there is a certain thing that you know by default. All right, so you have linear algebra, this one here, you hit enter, that guy there, dot, then inverse. This is used to get inverse of the matrix. All right, so we are trying to get inverse of x transpose times x. So we've gotten x transpose evaluated here. All right, x transpose has been evaluated there, and then you use this multiplication. So there are two ways you can use the you can multiply matrices. You can use this at and then multiply by x, or you can use numpy dot notation. If you use numpy, you can use dot notation. Dot notation you can use to multiply two matrices together. All right, so but if you use at represents the normal multiplication, so we don't use star as multiplication here. Normal programming, normal this thing, when you're using when you want to multiply, like say scalar multiplication, like 2 times 2, 2 times 3, you use asterisk. But when you're multiplying matrices here, you use at sign. Okay, now so we have S transpose, at means the multiplication, times the actual x value. The actual x value. Please, am I still audible?
Yes, sir.
Yes, you are.
Yeah, so times the actual x value. I want to be sure we call it x. So yeah, times the actual x value. Yeah, so that's the inverse value. So everything we got here, we want to call that as the inverse value, and then we can then multiply inverse value by x transpose by this. So this inverse value can, let's see what that gives us. This pretty much, because I have this Grammarly something activated. I should have deactivated it before It's trying to see this guy as an error. So we have inverse value. So this gets the inverse value for me, though I don't need it for anything now. Please, is anybody raising their hands? Okay, someone wants to join. Oh, did I just remove someone? Oh, Mr. Abibullah, please, you can tell him in the group to join again, or
I think he's experiencing internet glitch from his end because it keeps coming in and going. So.
oh, okay. I thought I was the one that evicted him. All right, so this is the x value. All right, so the next thing I want to do is to then multiply my x value so I can get out my coefficient. So my coefficient properly, so I call that coefficient. So that is going to be the inverse value times, in this instance, at, right? Inverse value times the x transpose, we call it s transpose. So this one too, this should be able to help you. S transpose and then again times y. So inverse value, everything here serves as inverse value, then multiply by x transpose and multiply by y. So once we do that, we can get out the coefficient value. So we get that out. We have this as the coefficient that we got. So this is pretty much like everything that we did in the video yesterday. All right, the coefficient, which is the b, you have to coefficient value. Now we have this one 039 something, and then this one here. Now, so for us to make sense of that coefficient value, let's assign column to it. So we can say coefficient, I can use tab, dot index equals to x dot columns, right? Now, so if you get out your coefficient again, you would see that it makes more sense. So we have y value and we have units, we have x. So remember where we're coming from. So we have this value. So the next thing we want to do is to get our sum of square, to get our, first of all, our prediction. So this is y, the actual value, and then you have this, the units and the x value. Now let's get out the prediction, which is y cap. Now our prediction y cap, so let's call it, if we call it prediction or we call it y cap, prediction, this is equals to, remember, prediction is x times the coefficient, right? So we have this prediction equals to x times coefficient. We're supposed to have gone for break. X times coefficient. Then we have this prediction. So this is predicted value, and you know, you had your actual value. This is your actual value. This is predicted value if you use your linear regression. All right, so the next thing we want to do is to get how accurate our prediction is. and that will be through the sum of square total, sum of square residuals, and of course through the R square. So we'll go for a break for 15 minutes. We'll come back and continue this. Thank you. All right, welcome back. Welcome back.
Yeah, we're here, sir. You're welcome, sir.
Yeah, thank you, sir.
All right, great. So let's ride on. So the next thing we want to do is to get out our sum of square residual. So remember the formula that we wrote out for sum of square residual yesterday. Sum of square residual, if we denote it by SSR, is equals to y minus y cap, sigma y minus y cap squared, right? Sum of y minus y cap squared. So how we're going to have this is that, so if we have this y minus y cap is prediction, or you can just, since this guy is correct now, y minus prediction, then we want to square that out. So to square that, we use this. So this is y minus y cap squared, but we want to sum all the value because this is a series of value. So to sum everything up, we have this sum function that sums everything. So if you have a column and you want to sum all the values within that particular column, that column dot sum essentially gives that series of data that summarizes or sums up the data. Okay, so if we put out SSR now, we put out SSR, we'll see the SSR value. All right, so the next thing is to evaluate SST. This is manual model that we built, and it's essential for us to lay the foundation. So we have SST. So if you lay down SST, remember SST is y minus y bar, squared as well. Then we'll find the summation where y bar is a mean, is the mean of y. Okay, so there are several ways you want to do this. Maybe you want to evaluate your mean value. Maybe you say y mean. Y mean, you have the number of ways of doing it. You can use npi mean. So npi has numpy as mean. You can use numpy to get the mean out. Mean of y. This would get the mean value of y. All right. Or you can use from y itself. You can use the pandas. What we're using here is numpy. So you can use panda to also equally calculate y. If you're using pandas, you just say y dot mean. Y dot mean, just like here when we say this dot sum. All right. So numpy mean, evaluate this mean value. We pass this as an argument, and that evaluates the mean value for us. So that is y bar. This is y bar. Right. Now, so the next thing we want to do is pass in the y bar into the appropriate equation of SST. Sum of square total is equals to y minus y bar. So I'm going to put this in brackets. Y minus y bar. In this case, y bar is mean. All right. Then we square it. Then we sum everything up. So if we square this, similarly, we have this. and then we can sum everything that we've got using the numpy the panda sum. So we have this here, I guess. All right, so doing this, all things being equal, we should get out our sum of square total. Now, so the next thing we want to do is to get our R square value, which measures the level of accuracy of our prediction. So our R square value is, remember we said, is 1 minus SSR rather, divided by SST. 1 minus sum of square residuals divided by sum of square total. Now, so this is, let me write this as comments, because that's not, so let me, of course, this will evaluate, because we have this guy here. SSR is evaluated, this one, so that formula is actually very correct. So if you put R square out, which is equals to 1 minus the same thing I wrote up there, SSR divided by SST. Okay, R square will give us this. So our value is 98.8. Confidence level is almost 1. So our prediction is almost very accurate. So when you build a model, the reason you want to check your level of accuracy is when you build a model, when you test it with certain data, you want to be sure that if the model is giving you maybe less than 70%, maybe what you want to use is not linear regression. Maybe the data is not really linear. Maybe you want to check logistic regression. Maybe you want to check other type of regression algorithm to do that. But this kind of data, Hall's having 98.8. I think the one that we did earlier is even 80%. So this is almost a perfection. So the next thing I want us to introduce is, let's plot this out. Let's plot this value that we have on a graph and then see how the data aligns. Let's see how the data align. So I'm going to import matplot library. So let's see if we have matplot library already. So to plot graph here, we're going to be using matplot library. So if you can import it from where you have imported all the importables, or you can do it within that execution there. So the ball is pretty much in your court, because we are running everything within the we are running everything within the notebook. So let's say I import it right here, but subsequently we're going to be importing everything that we need at once. All right, so that our program looks professional. So we say matplot library. Okay, so if we import matplot library, and then let's see if you have matplot library. So you can run this. So this module is not found, so we're going to go ahead and install it. So if you run it like that and this module is not found, we're going to go ahead and install it. So let's quickly go and install that guy. So I'm going to install it within the same shell. So we're going to pause this guy. We're going to stop our server. We're going to stop our Jupyter server and then quickly install pip install matplot library. Matplot library. So that is going to download that guy and then have it installed. If you have it installed before, congratulations. If you don't, quickly download, ensure that you have good connections. That's going to go ahead and continue that way. Okay, so this guy requires OS permission. So what you're going to do is that you start your prompts in an elevated manner. So you can start this with administrator and then install that guy matplot. So if you have that error, you need you to run it as the super user. Matplot library. So now the package is successfully installed. So it's still complaining that some of my packages are outdated. All right, so if you have that guy installed, fire up your Jupyter again. Jupyter Lab. So for some of us who are full-time developer, Jupyter is actually developed, is running on Node server. If you have noticed, it's running on top of a Node server. Okay, now some of these your variables are not available, because you see if you try to call X, you see error because these guys are not run. So what you're going to do is, let's say we want to run all cells. We want to run all cells so that all the variables are loaded into the kernels. So we say restart kernels and run all cells. So we say do that. So it will run all cells from beginning. So it runs all cells from beginning, everything. So all the variables we get loaded. So if you go straight into these things when your server is just down and you just wake it up, you begin to see certain error that you didn't see initially. That is because each of these cells work independently or dependently. Sorry, each of these cells depend on this. So if you're trying to use an inverse value here and it was declared earlier, it's using what was declared earlier. So if you come here and use it and this cell has not run, it means that that variable has not been loaded into the memory, and you may get something like that guy is not defined. That's why we had to run everything to be sure that everything is still within this thing. So please, do we all have our matplot installed? Let me know if I should continue, or some people
Yes,
have
sir.
run into errors. We are good?
Yes, we're good.
Perfect. Please, if you want us to take it slow, Plus, beyond Mr. Suleiman, please, I need another consent so that I can fire on. From the ladies. From the Office of the Women Affairs.
I'm invited, sir.
All right, thank you. All right, thank you. So, I'm going to now import. Is this is where we're working on, right?
No.
It's not the one.
We are now
Yeah.
at matplotlib the graph.
Oh, it's this one. Is this other one, right? Yeah. Is this other kernel that we're working on? So let me see if this guy is available before I run. This one was that one of yesterday. So what I was saying is you can see data is not defined. And that's why I said that you should run it from, you should restart the kernel and run all cells. So that all your value will be loaded. And that's why it's important that you name your files, so that's the mistake that we did now, because both of them are untitled 1. So this guy runs all my cells from beginning up to the moment, so that we're sure that everything is loaded into the memory. So once, okay, I think it's loaded. So the next thing we're going to do is let's import the matplotlib library. So this is a bit long, so we may want to import it as something. So let's say I use the PLT, or I can use anything else, just like I've mentioned. If we use it as an alias, so that it's a bit more convenient to use PLT than to be writing this way all the time. So let's see if PLT is available now. Yeah, so that module is loaded and it shows us where it's